So hi again, folks. Richard Jones. Here's a diagram of a fairly generic IoT solution. Most IoT solutions will have a number of these components in them. And when we talk about what an IoT solution looks like, we typically break it down into three elements. The things on the left-hand side that are actually sitting alongside the machines you're monitoring. The insights. This is where all the data processing happens, and I believe you've had a look at some of those components in one of the earlier sessions. And then on the right hand side, how you actually start to close that feedback loop and start taking actions. In this session today, we are talking about the intelligent edge for IoT, so we will be concentrating on the items in the left hand side here, and also looking a little bit at IoT Hub, which is our cloud gateway. Now, when we talk about the edge, we always talk about devices sitting on the edge as being a spectrum, where we start off from the left-hand side with the most basic, say, a sensor or actuator that doesn't actually have any compute footprint at all. And then as we move across to the right-hand side, we see increasing compute footprint. So the first proper IoT device there is an STM32 microcontroller. We've got an Azure Sphere device that I'm going to talk about, a Raspberry Pi. And while we never advocate using Raspberry Pis in production environments, of course, it's always useful to talk about the Pi as a reference point for a compute footprint and the amount of power that it's got. Moving further over to the right, you can see more industrial gateway and server class devices, and then all the way up to that big box on the right, which is Azure Stack Hub. So it's your own Azure data center in a box that you can pull into your own data center if you wish to run Azure workloads and maybe for reasons of data sovereignty. But there's the edge spectrum. As we go across, of course, we've got a high compute footprint. We can run more advanced workloads. It does come with a higher cost. And of course, we have a choice over what underlying chipset we use there. If we want to run deep neural network artificial intelligence models on the edge, you might want to use GPU or FPGA technology to run those workloads in a more efficient manner and certainly faster. And thinking about Microsoft's specific offerings in this space then, on the left-hand side, we have Azure Sphere here, which I'm going to go into some more detail on, and Azure Rtos, which is a result of the purchase of the ThreadX real-time operating system. As we get into IoT devices, we need, of course, to connect them into the cloud to our cloud gateway, and we offer the Azure IoT Device SDK, which comes in a number of languages and can run on a number of platforms. And we just make that whole conversation with the cloud a lot easier by going through that SDK. The next two devices here are both based on Azure IoT Edge technology, which I am going to cover as well. And you can see there that the edge devices, that picture in the middle there, that's there to represent a range of devices built by our OEM partners, still running the IoT technology, IoT Edge technology. And then Azure Stack Edge is a first-party Microsoft appliance that we offer as well, that you can buy on a subscription basis. And then up to Azure Stack Hub that I mentioned before, your own Azure data center in a box, and finally Azure itself. So as Ella was talking about that compute fabric, this is what it looks like from a Microsoft offering perspective. So let's go into a little bit more detail on Azure Sphere. Azure Sphere was first made public a couple of years ago now, and it's come out of a lot of learning that we've experienced in Microsoft on security. You can see, and you all know, of course, how important security is to Microsoft and how much we invest in it every year. When we were thinking about IoT devices, we realized that a lot of those lower end MCU devices that we talked about earlier, they're very cheap, typically $1 or $2. and they're great at what they do, but they were never designed to be connected up to the internet. They just don't have the right security mechanisms and security stacks. And some of the learnings from Xbox, many of you will have Xboxes at home, I'm sure. We have learned that in order for a device to be considered highly secure, it must possess all 7 of these properties that I'm showing you here. The first incarnation of the Xbox had only 2 of these properties. The next incarnation had, I think it was 3 or 4. And then starting with the Xbox One generation, they had all 7 of these properties. And you need all of these 7 properties there in order to consider that device highly secure. A couple of really useful links there that I would encourage you to look at, and I'll share those links with Alana after the presentation. So from all that learning, we decided to create something called Azure Sphere. And Azure Sphere is an end-to-end solution. It has 3 component parts. The first is a specific piece of silicon. It's a system on a chip that we designed. The second element is a secure operating system. It's actually a secure cut-down Linux kernel that runs on one of the cores on the Sphere device. And then finally, a cloud-based security service. And all of these 3 things together work to realize those 7 properties I was talking about earlier. So the chip itself, as I mentioned, it's a system on a chip. So you've got multiplexed I/O, many different types of interface adapters there, SPI, I2C, etc. And first of all, we have the 2 ARM Cortex-M4 processors, which you can deploy code to, and you can either deploy that code natively or using a real-time operating system such as Azure Rtos for your real-time needs. The Sphere chip also has built-in Wi-Fi, so it can connect straight to the internet in a very secure manner. We do also enable you to do this via wired Ethernet connections as well, but the Wi-Fi is actually built into the chip itself. All of the elements on this system on a chip are protected by firewalls and controlled by something called the Microsoft Pluton subsystem, which is really the kind of the secret sauce to this that we've added as Microsoft. Some memory and RAM and some flash as you would expect. And then finally, the Cortex A7, which is where you would typically run most of your applications. This is actually where the Linux subsystem lives. And most of the applications you deploy would normally go on to that A7. So Sphere itself, as I mentioned, is a chip. It's a operating system and it's a cloud service, so cloud security service, all 3 of which work together. And we're working with partners now to develop modules based on Azure Sphere. So for example, there's a module by Kio, which includes cellular connectivity. We've also announced a partnership with Qualcomm as well, and they're developing a chip for cellular communication as well. And to enable brownfield scenarios where you don't want to design a new device, including the chip from the ground up, you can connect a Sphere-based module to take care of the secure internet connection for you and connect that back to your existing devices using, say, Ethernet. And this is actually what Starbucks do with their coffee machines. This was announced quite a while ago now. So that's how they've been able to connect their coffee machines up for remote maintenance and monitoring via one of these Guardian devices. So moving on to Azure Rtos, I mentioned earlier that Sphere itself could run an Rtos on its M4 cores. And I mentioned that Microsoft purchased the ExpressLogic ThreadX operating system. For those of you not familiar with a real-time operating system, it's typically deployed in these verticals here where you have a need for deterministic and critical performance. Preemptive multitasking operating systems, of course, just aren't suitable for this environment. And so the acquisition of ThreadX has been a fantastic add to our overall portfolio as Microsoft, because ThreadX is there in well over 6.2 billion things now. So many devices are running Azure Rtos now. So it's been a great acquisition for us. I'm going to come on to talk about IoT Hub in a little while, but one of the things I wanted to mention, particularly around constrained devices, is the SDK that I also mentioned earlier. When we want to communicate with the cloud gateway through Azure IoT Hub, we do have this range of SDKs in multiple languages available to you. We have now released what's called the Embedded C SDK, specifically for constrained devices. So more of your sort of MCU class device, where you write your embedded C code, and that sits on top of the MQTT and TLS implementations. We typically recommend MQTT for these constrained devices, and you always need a TLS stack there, because IoT Hub will only allow TLS encrypted connection, so you would always need to have that library present. The latest thing that we've announced is specifically in Azure Rtos, we've embedded that SDK with what's called a convenience layer. So it really is very efficient in terms of its footprint and size, and this is the best way to connect to the internet securely for these constrained devices. I want to talk a little bit now about IoT Edge. So we've talked about constrained devices and secure devices. What happens now when we're on that bigger class of devices? We start to move over to the right of that edge spectrum. Perhaps we want to run more complex workloads. And the scenario here, the industry demanded that with this typical pattern of things, insights and actions, that was all very well. We could send data up into the cloud, do some processing, take some actions, perhaps close that feedback loop and send information or configuration back to the machines on the edge. But what happens when you don't have any connectivity, or perhaps connectivity is expensive or unreliable, maybe over SATCOM in remote areas, etc. So to solve that problem, we said, right, we need to take some of these workloads and push them down to the edge, so you can get the value and the intelligence right where you need it without having to send that data to the cloud, which of course there may be data sovereignty reasons why you don't want to send certainly a full data set to the cloud as well. So the way we solve that, and in this example here, we've got a video camera example, and of course streaming live video from multiple cameras up to the cloud would either be very expensive or perhaps not possible at all. So thinking about how we would achieve that, we can create some code that would run in the cloud. We might even use some of the Azure Cognitive Services. But in order to get that code down to the edge, what we do is create a container registry and then containerize that code in just using Docker compatible containers. So convert that code into those containers and define a workload description that then gets pushed down into the edge device with the Azure IoT Edge runtime. And that device then will pull down the containers that it needs, and it can then execute all of that code in order to fulfill the use case, get the inferences when there is no connectivity present. So a little bit of a deeper dive inside there. The IoT Edge runtime itself has included with it something that looks a little bit like IoT Hub. So if you do have devices that can speak natively to IoT Hub, you can use this as sort of a gateway mode, if you like, and it will forward on that traffic, buffering messages that it can store if it doesn't have connectivity for a period of time. But you can see here we've got an OPC UA module, which is available on Marketplace, and I'll come to that in a minute, for devices that speak OPC UA as a protocol. We've also got Azure Functions, Azure Stream Analytics. So all of these things that you're used to working with in the cloud, we can actually push down to the edge as well. And IoT Edge is, of course, managed by IoT Hub using the standard mechanisms within IoT Hub, device twins, etc. We call them module twins for IoT Edge. So you can see, as Ella was talking earlier, we're really getting some consistency in terms of this compute fabric across the edge and the cloud, allowing you to run the same workloads and in some cases the same code across cloud and edge. We do see IoT Edge typically deployed in one of three ways, either as a transparent gateway where those devices can speak to IoT Hub, but the IoT Edge runtime is perhaps sitting in a DMZ as part of the network and is just forwarding that device telemetry and anything coming back from the cloud to those devices. Second pattern protocol translation would be perhaps where you have got devices that are speaking OPC UA as a protocol, and then what you're doing is pulling data in, but only presenting one device identity into IoT Hub. And finally, identity translation, where each of these downstream devices do have their own identity. You want them to be recognized as unique devices in IoT Hub. Perhaps you want to take advantage of the device primitive, so the device twins, which I'll come on to in a minute. So that's how we see IoT Edge deployed. I mentioned that you can create modules for IoT Edge in Docker containers, and here's another link here that I can share with you. So on Azure Marketplace, which I'm sure most of you are familiar with, there are specific offerings in here to run on IoT Edge. So for example, Azure SQL Edge, you just pull that down as a container and then you get a lot of the Azure of the SQL Server functionality there, and there are a lot of third-party offerings here as well. So this is, certainly an opportunity for ISVs to develop modules and put them in the marketplace for other companies to pull down and use. So I mentioned Azure IoT Hub, and this is the part where the intelligent edge and the intelligent cloud really come together for us as part of our IoT offerings. I'm sure many of you will be familiar with this, but it is our bidirectional secure cloud gateway. It speaks one of the three protocols there, HTTP, AMQP and MQTT, the secure version of those only. IoT Hub never initiates connections to a device. It's always the device that initiates connections to IoT Hub. So you don't need to have open incoming ports. And it is highly secure because each device does have its own identity and its own authentication key, or you can use certificates as well. For deploying and provisioning devices at scale, we have something called the device provisioning service, which allows you to very quickly and easily deploy your devices without having to put in the full connection string to Azure IoT Hub. That's all part of that provisioning process, as long as you do start with some kind of root of trust. Going back to the Sphere conversation, Sphere has on it a hardware root of trust, which is used as that unique identity to seed this process in terms of connecting into the cloud, and then forms a chain of trust for building up the device provisioning and finally connectivity to Azure IoT Hub itself. So a little bit of a look at IoT Hub then. What can it actually do? It's loaded with features. It's really feature rich. As I mentioned, it's got the device provisioning part in there that links in very closely with DPS, and there's a registry store within Azure IoT Hub, so it knows what all of the devices are that can connect to it. There's a device to cloud send endpoint for that telemetry, and then you can pull that data out of the back end as well and send that off for processing. And that endpoint on the service side, as we call it, actually looks a lot like an event hub, because originally IoT Hub was based on the Event Hub code, and then became more richly featured and specific to many outward-facing devices in the wild there. We can also send messages back to our devices as well, so we can send them commands. You can also create custom endpoints. So for some of your telemetry that's coming in, you can query on certain properties and then route certain messages, say messages labeled as a high priority or as an alert, to a number of different endpoints, including a different event hub, storage or service bus. We also have something called device twins that allows you to replicate properties to and from the cloud and the device. Really useful for configuration items. And we can call direct methods as well, so that behaves like a remote procedure call. So I'm going to speed up a little bit here because I think we are coming very close to time. So just a few links here if you want to get started on IoT Edge and develop modules for the marketplace, and another few resources as well. Great number of links there. I'll just call out this one as well, aka.ms/learniot. There's some great modules and tutorials there. I would encourage anyone interested in IoT to work through those modules. They really are very useful.